good evening, and welcome to our open development stream for February 2021. And today we're going to be talking about the Scratch node that you guys have requested. And as you can see, this is the initial port of it already. This is just part of a test to see if it's temporarily stable. If I render a whole sequence that doesn't change anything. So yeah, this is what the final result looks like when you're really pushing it. Let me just get a little bit closer here. Maybe minus 1.2 meters. Actually, minus 1 should be all right as well. And that gives you an idea of what the Scratch node does. So basically, it computes the distance in the UV space to a bunch of randomly rotated lines. And if the line is hit, then it will output some values. So let's have a look at the shading graph here, which is super simple. Let me just make this a bit smaller. Does that work? Yeah, it works. All right. So what we have the Scratch, which is using the default UV projection, but you can use any projection you want to. It does work in UV space. And you have the option to change the density, the width of the scratches, offset, kind of rotates them. And then you have a roughness default value, as well as a minimum maximum value, and then an anisotropy. That's a bloody terrible word to pronounce. Default value and a minimum and maximum there as well. So what this essentially does is you have a roughness, anisotropic, and rotation output. Let me just remove this mask because that doesn't really work. And you pipe them into the principled BSCF shader, into the roughness, anisotropic, and rotation, which is the anisotropic rotation input here. But you don't have to use all of them. And for the roughness, for example, if I'm just do it this way. All right, there we go. So if a line is not hit, if we're like in this case on the smooth parts of the sphere, then it's going to use this roughness value. Otherwise, if one of the lines is hit, it's going to output a value between the minimum and the maximum, which is 20 and 30% for the roughness. And the same is true for the anisotropy. This is super exaggerated. If I want to tone it down, I'm just going to turn on the anisotropy, and that will just be the roughness change. One reason why this takes a bit long to render is because I've got lots of samples on the sphere. And yeah, that kind of slows things down, but it's the only way to really get those lines to show up. And if I turn down the minimum and maximum roughness to something like, let's make it 15 and 20, you will see that it starts to get a lot more subtle. The width here is a percentage in UV space, 0.1%. I mean, something between the range of 1% and lower is reasonable. If you go too high, then the lines are going to be so thick that they're going to cover everything. And yes, this is super exaggerated here. One thing you would probably want to do is decrease the density to something like, let's make it 2%. And maybe even decrease the roughness to something like 10 to 15. And this way you have fairly subtle scratches here. Yeah, sorry, Steph. Wrong live stream. No free Adobe products here. All right, and they just increase the whole thing again, and let's do something else. I'm going to take the output of the roughness and turn that into the color of our standard material, and this one has the luminosity set to 100%. There we go. And this is basically the roughness output that the node creates. The darker areas are the default roughness. I'll just put that to 0. There we go. And then you have the minimum and maximum value, which is the roughness for things that are on the scratches. And if I turn this to 0 and 30, you will notice, or maybe even 0 and 100, you will notice that there's some noise on them, but it's very, very small noise. It's not Perlin noise or anything, but it's really noise that changes from one pixel to the next. And that's what the original code actually uses. So I would recommend to keep the minimum and the maximum values within similar settings. Octane would have to use the OSL node. Although it's going to operate, it's going to be similar to this, but I did tweak the code a little bit. All right, so this is essentially what it does. If you increase the density, I had 10% before that. I mean, this is also a nice way for you to visualize the values and to see where the lines are, regardless of what the surface is. Let me just change this to 100 and 100, and you can even use it, to create patterns like this if you want to. And you can increase the density even more. Let's make it 25%. And at one point in time, it's going to be, super, super busy. I can also turn this down to 1%. And if you increase the width from 0.1 to 1%, then you will see that the lines are going to get very thick. However, this does scale with the UV space. In this case, it's a default UV. If I would apply a spherical UV and change the number of tiles, then the scratch effect would grow bigger or smaller as well. So let's just decrease the width again to 0.1. And I might change the default values here. Offset, let me just look at the code to see what the offset does. Where's my code? It's not here. Here it is. What does the offset influence? It offsets the direction of the anisotropy. But yeah, that's it. Okay. So this doesn't really affect any of the shapes of the lines. So yeah, this is a nice way to visualize it, to see what's going on. One thing that you might notice is that the edges of these scratches are sharp, and that's just the way it's been designed. And they are also fairly longish. I'm not sure if I can expose a parameter to change that. I might be able to do that, so you have shorter scratches. But since they usually are only a very subtle change in the surface, so something from 5 to 10% or so of the roughness, and that only affects the roughness, maybe even 1 to 5% or so, it should be okay. One thing I can't extract from this is a bump map. I would like to, but yeah, I really can't. So if you use a smaller value like this, you will notice that it hardly shows up. So you need some values for the roughness. Even more. Maybe 10, 20. Yeah, now it's starting to show up. So it depends on whether you want a more subtle effect or something that's a bit harsher. So yeah, this is like the super extreme case. Yeah, the offset is basically an offset on the rotation of the anisotropy, and I should certainly put that down there and group it with the other settings. So yeah, this is essentially what this does. Not much else I can really mention here. It might even be possible to just leave the roughness as is and just change the anisotropy to something else. I'm not sure if that's actually going to affect it in this case. No, probably not. I'll have to see how that changes things. You can't actually, but that is a good idea. I could probably just add a weight input. It should be working because the outputs are valid, but they just go straight into this. And that should work because there's a default UV. I'll probably need to check it. One thing I could do is just create an animation where I animate those and see what happens. So yeah, one thing that's also going to be added is there's going to be inputs for all of the values. So you could change the density or the width and things like that with nodal inputs. And I will add a weight input. So you can use that as a mask to say, okay, I want scratches in this area, but not somewhere else. That's a good idea. But yeah, other than a few tests, the only thing that is missing are the nodal inputs, loading and saving of the settings, a small rearrangement of the user interface here. But the core algorithm is working. And one thing I also wanted to check is if there is going to be noise when this is animated. I did check that a few days ago, and it seemed like there was a bit of noise, but I still have to check it with the new version here. Yeah, there were a few things in the original code that had me stumped. For example, the minimum and the maximum roughness. Basically, what it does is it takes the value between both of them using a noise as a weight. And the odd thing is that in the original code, the noise that they're using would always return the same value, so it wouldn't really interpolate between those two, but always pick the same value between those two. Oh, sure, I can do that. I can sure do it. But it's not going to be much different from the roughness, really. Anisotropic into color. It's essentially the same thing. It's the same thing, except that it allows you to set different range of colors. The more interesting one would be the rotation. I'm going to plug that into the color. And what does the rotation depend on? Just a second, let me look at the code. Outer direction depends on the offset, the internal direction. Yeah, it should show something, but for some odd reason it doesn't. It doesn't depend on the... No, okay. I wonder if that should be more randomized as well. It's odd because the direction should change more. And direction is... Oh, okay. Bug. But it's one that I can actually fix fairly quickly. Let me just quickly recompile this. And then we should be able to... Yes, it's a fixed seed. I wasn't sure if I was going to keep that same noise function, so there's no exposed seed. If I use this noise function I'm using at the moment, that one actually has a seed, so I could also expose that, and I would. But if I swap it out for a different noise function, it doesn't have one, that won't be a seed. The original OSL node uses what's called a hash noise, and that doesn't have a seed. So it may come. All right. Let's start rendering this again. These are the default values. So I'm gonna take the rotation, put that into the color, put that into the surface. Yeah, this is more like it. This is the rotation. So roughness 10, 20 to 30. And if I add an offset here, then it just basically adds to them. But since it's a rotation, it's probably going to wrap anyways. All right, so let's see what this one looks like. It would probably make sense to have like one sample animation where it's just the where basically the roughness changes, but one where the anisotropic values change and one where the rotation change. And maybe even turn those into a GIF, GIF, and upload them to the docs. But yeah, the underlying noise function, the noise function used for the randomness here is it's almost like a white noise or something. So yeah, and I might change the range for the width value. But yeah, that's just playing with the parameters to see what's good here. 10, 15 to 20, something like that. Maybe even increase that to 50 and 60. And yeah, that would slowly give you something. So yeah, that is the Scratch node so far. So we have the mask input, the rotation works. And yeah, that is the current state of, let's make it 90 and 100. Yeah, that kind of gives you that effect here. could lower this. That was coffee, hot coffee. So yeah, that's the current state. I'll see if I can get this released to you as like a preview version by Monday or so. Should be possible. And then you can play with that. I wish there was, yeah. Swirling, not really. I mean, to basically have them rotate properly. It does depend on the UV though. One thing that's kind of surprising me here is that the scratches are fairly long, but that's because I'm using the default UV. I've got a spherical projection here. If I use that, it should be the same, yeah. And if I change the number of tiles, and I think if I increase it, then, yeah, it was a bit too much. Let's just make it, maybe 2 or so. Then the scratches are going to be smaller. As you can see here, if you can actually see that on the stream. So it might be possible to actually, turn that down to 5 tiles, but to counter that, increase the width of the, that's too much. Increase the width of the scratches a bit. And that should give you smaller but thicker scratches. Yeah, it does. So depending on the UV, you can actually play with that. I wonder if I should actually add something like a scale option that essentially scales the UVs before they're being used, because that would allow you to do something like this without changing the actual UV projection. So yeah, so mask input, scale option, render some samples, and expose the seed, since it seems like I will be using this this noise function. The initial version out of this actually used a Perlin noise for scratches, and what happened is that they were all almost going in parallel all the time, and that's because Perlin noise usually has a very low frequency, so it doesn't change that much from one sampled point on the surface to the next one, and it completely counters what this texture is trying to do. You need something that is really super noisy and not like smooth and Perlinish in as far as the noise is concerned. That was the main thing, because once I had the initial code ported, I was like, wait, the code looks okay, but yeah, for some reason the noise just doesn't work the way it's supposed to. So yeah, the underlying noise is what makes this happen. Yeah, that's pretty much all I can tell you about this so far. But I think you can do lots of things with it, and I'll see if I can still further optimize it in terms of speed. However, I think I've reached a limit there. There's not much more I can do to really speed it up. There might be one more option I can expose. I'll see how that affects the final image. If that changes something, then I will expose it. And if not, then I won't. But that might be something that allows you to speed things up a little. So yeah, that's pretty much all I can say about this rotation 50%. You mean the offset? Yeah, but getting a better CPU is cheating. So yeah, that's 50% offset. Completely different picture already. So yeah, should be able to get this by Monday. Um, Also, one thing I would like to remind all of you of, we're still kind of, I suppose, beta testing the wheel rotation node. So please hammer it if you can. Once, probably towards the end of the month, I'm going to start writing the motion modifier and a channel modifier. So if there's any feedback before that and you have any issues or bugs or feature requests for the wheel rotation node, I would appreciate them within the next couple of weeks. And also one more service announcement. We currently have, I think, 66 paying patrons, and we would certainly appreciate more. If you can help us out, send out links to the videos, to the nodes, try to help us get some more patrons. I know it's difficult right now, especially with the current state of Lightwave, but yeah, we would really appreciate it if you used your powers of of social media to give us a hand there. Exactly, spread the word. Well, if it was a proper, devil's number amount of patrons, I wouldn't complain if you had 666. Well, you can't really do a pass-through because, you mean an option where it's just not being computed? Well, I suppose a quick pass-through would be to disconnect, as stupid as that sounds. Or you can set those to 0 because they're being added to the original roughness or anisotropy value. But yeah, I could probably do a pass-through where it disables those and doesn't do anything. And yeah, as I mentioned before, I mean, you don't really have to use it as a roughness and rotation. So let's be, what shall we take? Multifractal. Multifractal is, it's boring. Hybrid multi, I think, is a bit more. Yeah, right, fine. Let's just be super funky. Red, yellow. All right. And I'm going to put that in here. Material mixer. Bam. Bam. And all of a sudden you have something like this. Yeah, I'm going to expose the inputs. Yeah. All of the settings here are going to be inputs, plus there's going to be a masking input, or not sure what I should call it. Mix, mask, strength, there we go. A strength input. Which is actually not going to, I might even give it a, so expose it here in the user interface as well. So yeah, that's essentially the current state of things. It's not really an alpha because you're not really composing anything. The strength input would basically, for example, the roughness is being computed as okay. The output roughness is the default roughness plus some value between the minimum and the maximum you set here. If I had a strength input, then the output roughness would be the input roughness plus the value between those two multiplied by the strength. And that would allow you to fade everything in and out either globally or on a per spot basis, whatever, if you use a nodal input. So I think that's something that is certainly useful as well. And it's not really an alpha because you're not really using it to compose anything. Do I switch those two around? But yeah, so there are some more creative uses for all of this if you prefer that. Command light wave. So I'm sure you're going to find more uses for this. Actually, I was just thinking if you just use the main roughness output as a displacement, as a clip, or maybe invert it, then yeah, you could get some, like a nice threaded ball or something like that, which would probably kill Lightwave when it comes to anti-aliasing while rendering. But yeah, that's all there is really. And yeah, I think what's killing the render times here is just the number of samples. It's not the node by itself. So something to experiment with. And you should be able to play with this by the beginning of next week, hopefully Monday. And I'm also looking forward to what you guys come up with when using this. It's not that bad. The thing is that basically what it does is for every spot that it samples, it creates a set of what's called in the code is basically virtual cells. So it's basically imagining that around the current spot there is essentially a set of square checkers. And each set of those square checkers is where one of those virtual lines runs through. And then it checks if any of these lines touch the current spot. And the higher the density is, and the more of these virtual checkers it creates, the more line intersections it has to compute, and the longer it takes. On the other hand, it's smart enough that if it actually has found one line intersection, then it's not going to compute any of the others because all the scratches here, they don't have any transparencies or opacities. It's not like there's a soft fall off at the edge of these scratches. The logic in the node is, or in the shader, is essentially we're either on a scratch or we're not on a scratch, but we're not. There's nothing like the edge of a scratch. Which allows it to speed up things, but just, once it finds the first scratch it's on, that's the one it's going to use, and it's not going to search for any more. So the worst case scenario, actually, when this when the shading node renders, or when the shader renders, is areas where there aren't any lines that cross it, because in that case it actually has to check for intersections against all of these virtual blocks that it created. And one thing I could do is basically expose the number of blocks that are being created or being checked against, which kind of interplays with the density. And that should speed up things as well. So yeah, that's going to be something like an advanced setting or something. Maybe I'll group that with the seed. What's it called in the source code? In the source code, it's division. So I might just expose that here together with the seed to give you a chance to basically tweak the thing for speed if you want to. But yeah, that's all I can say about this. Also, if you have played with the texture repetition node and have any feedback, I would appreciate that as well. And yeah, other than that, thanks for joining us. And yeah, we'll talk to you later this month for the Q&A stream, at least our patrons. And yeah, we hope you like what you've seen so far. I certainly do. I think it's going to be interesting. And yeah, you'll get your first copy next week. Until then, have a nice weekend, have a nice evening. And thanks a lot for joining us. Bye bye.